All right, ladies and gentlemen, we have composition of functions. Now, a function would be something like f of x equals 3x plus 2. It's a straight line, so it's that identity function, but it has been moved with a slope of 3 and shifted up 2. So it's 3x plus 2. We've taken this one, g of x, which is x squared, but we've now shifted it down 1 unit because of the minus 1. Now what we're going to do is we're going to take these two functions, we're going to combine them in a number of ways. We've done this in previous years. This should not be anything even slightly shocking. For f plus g of x, all I'm going to do is take f of x, I'm going to put a plus sign, and then I'm going to put g of x. Now, you could, of course, and need to, simplify. In this case, you end up with x squared plus 3x plus 1. Okay, that's putting f of x plus g of x. Graphically speaking, what it does is it takes this graph, and whatever the y values to this graph are, they add them together. So, for example, these are both above the x-axis, this point and this point, so you're going to add the two values up. Add the two values up, but as this goes negative, it's going to start canceling these out. This goes real negative, it's going to cancel that out. As this goes negative, this is going positive, so they begin canceling each other out, so that if I were to take and to graph this function, you'll find that it's very positive in here when I put the positive bits together, but they cancel each other out going towards 0 when you get real negative and some positive. And then as this one goes way positive faster than this one, it goes positive yet again. So you're just putting the y value of this plus the y value of this over and over and over and over again until you get a shape like this. Now, that's how you deal with it symbolically, that's how you deal with it graphically. So let's do minus. Come up with 3x plus 2 minus. Now, I need to put x squared minus 1 in parentheses because it's minus the entire quantity. So I have to put the whole thing in terms of minus. So I would come up with negative x squared plus 3x plus 3. If I were to try to graph that over here, it's going to be y equals and graph that guy. You'll notice that it's subtraction. So I'm taking this function and I'm subtracting this from it. And so it makes sense that this is going to get flipped over because I have a negative in front of this whole piece. So it makes sense that I'm going to get a negative parabola here. Now, f times g of x, I have a small problem because this is a two-part function. This is a two-part function. And so they need to go in parentheses. If I were to try to put this together, I'm going to have to FOIL it out. So I come up with 3x cubed minus 3x plus 2x squared minus 2. And putting all that together, you'll notice when I go to my calculator, I just didn't simplify, left it all together, and I get this weird thing, which does have a cubic shape in it. And by having a cubic shape, it does make sense that this guy right up here is going to be a cubic shaped graph because I have a cube for this power. Now, we get down to the next bit of the puzzle, and we have f of g of x. Now, if I ask you for f of 2, all you would simply do is you would take 3x plus 2, but you would plug 2 in instead of x. If I said f of 17, you would say 3 times 17 plus 2. If I said f of Bob, you would say 3 times Bob plus 2. You're going to put whatever I say in for x. Anything that's behind the f. Well, what's behind the f? This notation, FOG. Quick refresh. F of 2, you're going to put 2 in for x, so it's 3 times 2 plus 2. F of 17, 3 times 17 plus 2. F of Bob, you're going to put Bob in for x, so it's 3 times Bob plus 2. If I have FOG of x, that means the same thing as F g of x put in for. So I'm going to replace the x with g of x. The best way, and the way I recommend that you do this, is you take the outer function, which is f. and you leave a big fat open parenthesis. And whatever the big fat open parenthesis gives you, says put g of x in for it, now you can simply substitute x squared minus 1 right in for that. You're going to shove it right in where x was. And in this case, you're going to end up with 3x squared minus 3 plus 2 minus 1. And you go ahead over here, and we can go to y equals, and hit enter and graph. And you see that we come up with a square. Well, it's square over here. It's shifted down 1. So it makes sense that this function right here is going to be shifted down 1. Now, in the same way, if I have g of f of x, I'm going to take g, which is something squared minus 1, and I'm going to put f of x in for it. And in this case, I have this. Now, to finish solving this out, I'm going to have to FOIL 9x squared plus 6 plus 12x plus 4 minus 1. So you end up with 9x squared plus 12x plus 3. And you can graph all of that. The only one I haven't done is division. Now, division is going to work the same way. If I say, for number 6, f divide by g of x, I'm going to take 3x plus 2, put it on top, and take x squared minus 1, put it on the bottom. My only challenge here is that now I have some x's in the bottom, which means I can't have x equal 1 or negative 1, because that would make the denominator 0. Okay, a few more thoughts in a second. Okay, ladies and gentlemen, there are your 8 homework problems. Use that f, use that g, find all of these, simplify completely, indicating any problems with the domain. Make sure those are ready to go when you come to class.